Welcome to Hartman Math. This is lesson 3.6, where we're going to take cubic functions that are in standard form or polynomial form. We're going to graph them by factoring them, find the x-intercepts and behavior, things like that. So to practice for that, we're just going to start by taking an expression and factoring completely. So notice that this expression has 4 terms, does not have a GCF. So a lot of times when we're doing 4 terms, we want to take the technique of factor by grouping. So step number 1 is going to group with parentheses. And typically, most of the time, that's going to mean take your first 2 terms, group those in parentheses, take the second 2 terms, group those in parentheses, the plus sign stays in the middle. Our next step becomes to factor each of those groups. And that's typically going to be greatest common factor factoring. So we're looking for what's in common. They have a 2 in common, and both of them have at least 2 x's. This is x to the third, that's x squared. So our GCF for the first 2 is 2x squared. When we pull out a 2x squared times what is that? X plus 2x squared times what is that? 3. Plus, now we look at the next group. Factor out the greatest common factor for that group. I think it's just a 5. So we'll factor out a 5. And then 5 times what makes that? X plus 5 times what makes 15? 3. We factored in this strategy. What we're now looking for is what's in common. As our plus sign here is kind of our divider. Left side, right side. What do we see that's the same? A common factor. We have a common factor of x plus 3. So just like here where we saw the 5 and we brought it to the front, we want to do the same thing here. We want to take the common factor and it goes to the front. Common factor is x plus 3. Factor it out to the front. And then the second factor is just the leftovers. 2x squared plus 5 goes in the second group. We would often want to see, can we factor this? Really in 2 terms, binomial that we're seeing, the only strategy that we've seen so far is factor difference of squares. And it's not a difference. 2 is not a square. 5 is not a square. So we can't go beyond that. It's now your turn. Go ahead and pause the video here as you work through factoring the expression completely. Hit pause when you're ready. All right, so we're going to group first 2 with the parentheses, last 2 with the parentheses, keep the plus in the middle. We're going to factor each one, factor out GCF, greatest common factor, x squared. That's going to leave behind 3x minus 7. In this group, there's really nothing to factor out. There is no GCF, so we could think of it as 1 times this. Good idea to have that 1 here for later. All right, so we've got 3x minus 7 in common. That goes to the front. X squared plus 1 are the leftovers. If that was a minus, we could keep going. That would be a difference of squares, but we can't do sum of squares. So that's as far as we can go. So our next thing is going to be to use these techniques to go ahead and take cubic function from standard form, be able to factor it so we can find the x-intercepts, do the graphing from there. So no GCF for all of them. So let's factor by grouping. Now it's a little bit challenging here because we have this minus in the middle where previously that had been a plus. So there's a couple ways we can handle it. Here's the way we're going to do it. We're going to group and keep the minus 8x in the group and squeeze in a plus sign that was kind of invisible here. Plus the negative means the same thing as subtraction. So insert that plus sign. All right, in this group, we have x in common, x squared in common. Factor out x squared. And over here, anytime that the first term is negative, you want to factor out that negative. So negative, and there's a 4 in common. So we're going to factor out negative 4. Negative 4 times 2x makes that. Negative 4 times positive 1 makes that. Just a quick check. These are the same. Yes. So common factor goes to the front. Leftovers go behind. Now, can we keep going? Can we factor this? We can. That's a difference of squares. So, two sets of parentheses, x and x, 2 and 2, one's a plus, one's a minus, difference of squares. We got our function factored. It's now time to think about how we would graph it. There's our function. X-intercepts. Again, it's a 2 in front, so it's not going to be negative 1. We want to be careful about it. Set them all equal to 0 and solve. Subtract 1, divide by 2. Negative 1/2 comma 0, negative 2 comma 0, positive 2 comma 0. Our end behavior. Back at the beginning or right now, A is positive for 3rd degree. So starts low, ends high. Our roots are negative 1/2. Multiplicity for this one, which came from here, is an invisible exponent of 1. So the multiplicity is 1, and any multiplicity that is odd is going to cross. I think we have the same situation here as well. Invisible exponent of 1, that's going to be a cross, and invisible exponent of 1, that's going to be a cross. So we're going to start low, we're going to end high. So cross, cross, cross. Let's take a look at one more. Example number 3. So we're going to group them as we factor. Anytime that we have a negative in the first term, that negative needs to be factored out. So we've got a negative, nothing here, we've got x squared. So we're going to factor out negative x squared. So negative x squared times 2x makes that. Negative x squared times negative 5 makes that. Nothing to factor out here, so we can make that plus 1. Then we have a common factor, 2x minus 5. That can go to the front. Leftovers, negative x squared plus 1. It might be easier if we reverse that and say 1 minus x squared. Can we keep going? I think we can. This is a difference of squares. We're used to having x in the front, but it really doesn't matter here. If we keep it in this order, in our fronts of the two sets of parentheses, what times what makes 1? 1 and 1. In the back, what times what makes x squared? X and x. One's a plus and one's a minus. So our end behavior, remember back here, A is negative 2. It's negative, so we've got a flip of our end behavior. It's going to start high and end low. That's going to be our end behavior. We've got roots at set equal to 0. 5 halves. The multiplicity is 1. It's going to cross. That one's negative 1. The multiplicity is 1. It's going to cross. This one is positive 1. It's going to cross. So there are our x-intercepts. It's going to start high and again cross, 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 cross. That's it for today. I'll see you next time.